Hi, so for today we're going to talk about derivatives of logarithmic functions. This is still a part of a video in our series lecture all about differential calculus. Okay, so let's get started. In order for us to differentiate functions involving logarithmic functions, we have to identify or first familiarize ourselves or at least memorize the formula for differentiation of a logarithmic function. So we have to So for example, if we have to get the derivative of a certain ln of x, that is simply 1 over x. For x greater than 0, okay? So we'll be using this formula. So what happened to this is, simply this is dx over x. The derivative of x over the original function, which is the x. So as you can see here, the derivative of x with respect to x is 1. That is dx, okay? That is our dx. The general formula would be dx over whatever the function x, okay? So that is always true, okay? So the numerator will be the derivative of the inside function in the natural logarithm over its original function x. For logarithms involving with base, so we have the logarithmic of x, okay, with base a. That is simply 1 over x ln of a. Whatever the base here. The a here is the base of the logarithmic function. So if we differentiate this, the formula would be 1 over whatever the x here, x ln of a. Of course, if the x here is not simply x, let's say x squared, so that would be 1 over x squared ln of, let's say, base 10, ln of 10, multiplied by the derivative of the x, of the inside function here. So 2x. Okay, so that's the case for getting the derivative of a logarithmic function. So in order for us to really understand or to practice ourselves on how we are going to get the logarithmic function of this, let's try to have some basic examples. So for this video, we'll be solving at least 13 or 15, 14, I don't know, examples. So just please bear with me. We will start with easy ones, then we try to answer some hard problems, okay, difficult problems. So for number 1, we have to get derivative of y is equals to ln of 5x. So first, what is the formula? This is an ln. So this is 5x. So we're going to get the derivative of this 5x with respect to x, and that would be our numerator over the original function, which is 5x. So the derivative of 5x with respect to x is that simply that is 5. And that is over the original function, which is 5x. So as you can see, this is 5x. This could cancel. So we have 1 over x as our answer for this problem. Pretty easy. Again, the derivative of the inside function 5x over its original x, which is 5x. Okay, and for number 2, what is the derivative of ln of the absolute value of 1 plus x? And again, we're going to get a derivative of this inside function of the ln. So 1 plus x would be 0 plus 1. Because the derivative of constant is 0, the derivative of x with respect to x is 1. And that is over 1 plus x. And that is 1 over 1 plus x. So this should be our answer for our problem number 2. Okay, so again, the derivative of the inside function over its original function. Okay, so for number 3, we have ln of absolute value of x squared minus 1. So we have to get the derivative of x squared minus 1, that is 2x by power rule minus 0 over x squared minus 1. And that is simply 2x over x squared minus 1. X would not cancel because of the denominator, which has a subtraction sign. This is minus. We cannot cancel x there. Okay. So for number 4, let's try another problem. Okay. For number 4, we have the ln of natural logarithm of x over x squared plus 1. So what are we going to do here is, actually we're using chain rule in our examples here, but the formula still applies. We have dx over x or du over u. So what will happen? I'm going to use a more elaborated chain rule in order for us to solve this. If you wish to recall, we have dy. This is equal to y. Okay, this is equal to y. So to get the derivative of y with respect to x by chain rule, we have dy over du, and we have multiplied by du over dx, so that du's would cancel. We are leaving with dy over dx. So if I'm going to label inside the inside function of the ln as u, okay, I'm going to let u is equals to x over x squared plus 1. And I'm going to get the derivative of u with respect to x. That's our du over dx. So this is a quotient rule. So a quotient rule, what will happen? We copy the denominator x squared plus 1. And we differentiate the numerator that's multiplied by the denominator, that is 1, minus the denominator or low d high minus high, copy the numerator, and then multiply that by the derivative of the denominator, that is 2x over the denominator squared. Okay, so simplifying, we have x squared plus 1 minus 2x squared over x squared plus 1, we have squared. And what will happen here is x squared minus 2x squared is simply negative x squared. So we have 1 here, so that would be 1 minus x squared. Okay, over x squared plus 1 squared. Okay, that is our du over dx. So how do we find we already find the du over dx. How do we find the dy over du? The dy over du is simply this, dy over du. So our function now, okay, our problem now is rewritten as, a while ago, we let x over x squared plus 1 is equals to u. So the original problem would now be y is equals to, okay, ln of simply of u. Okay, because we substitute x over x squared plus 1 by u. So to get the derivative of y with respect to u, that is simply 1 over u. Okay, because we have substituted again u as x over x squared plus 1. So, but u is equal to 1 over x. Our u is equal to x over x squared plus 1. So that is 1 over x squared plus 1. So if we rewrite this, dy over du is simply equal to x squared plus 1 over x. Okay, and in order for us to get the dy over dx, which is the derivative of y with respect to x, what are we going to do? Finally, we have dy over dx. We're going to multiply dy over du, which is this, x squared plus 1 over x, with the du over dx. Our du over dx is this. So 1 minus x squared over x squared plus 1, we have squared. So what will happen? This is x squared plus 1. Okay, and this would be cancelled by one term here. So our answer, dy dx, is simply 1 minus x squared over, we have x here, multiplied by this, we have multiplied by x squared plus 1. Okay. And this is our answer for our derivative. Okay, for our problem number 4. Still, if you do the basic du over u, or the dx over x, you get the derivative of this, and you divide it by the original function, you still get this. This is only a more specific way of solving this logarithmic function using the elaborated chain rule. Okay? Okay, so for number 5, okay, we have y is equals to ln of x squared. So that's very simple. Y prime, again, the derivative of the inside function with respect to x, that is 2x over x squared. This should be cancelled. So we have 2 over x. So I'm going also to show you that the elaborated chain rule that we have used a while ago will yield also 2 over x. So simply if we replace x squared by simply u, okay, so u is equals to x squared. Our du over dx would be 2x. Okay, And this is our given. So if we get the dy over dx by chain rule, again, our formula would be dy over du multiplied by du over dx. So our dy over du, as you can see here, differentiate this with respect to u, dy over du is simply 1 over u. But our u is 1 over x squared. So if we use this formula, dy over du is 1 over x squared multiplied by du over dx. Du over dx is 2x. So simply we have 2x over x squared. The x would cancel, so we have 2 over x, which is the same as this. Okay? So I hope I make myself clear with that. Okay, for our next problem, we have to find the derivative of y is equals to square root of ln of x. So it's best if we encounter square root if we are going to convert this square root into exponential. So we have ln of x raised to 1/2. Okay? So chain rule, we're going still to use chain rule here. Okay, in order for us to evaluate this. So if we are going to have a, let's say, let's label y is equals to, label this ln of x as u raised to 1/2. So our u is ln of x, okay? And our du with respect to x, and that is 1 over x. And of course, we have to get a dy with respect to du, and that is 1/2 u raised to negative 1/2. Okay? Or in other words, we can have 1 over 2 u raised to 1/2. But u is equal to ln of x. So we have 1 over 2 square root of ln of x. Okay? By using chain rule, we have dy over dx that is equivalent to what? Dy over du multiplied by du over dx. So we have dy over du, which is 1 over 2 square root of ln of x. Okay? Multiplied by du over dx. Our du over dx is 1 over x. That is 1 over x. So our answer for this problem would be, okay, numerator times numerator, that's 1. Denominator times denominators, that is 2x square root of the ln of x. So this should be our answer for this problem. Again, we use chain rule here, wherein the whole ln of x, we labeled it as u. We substitute it as u because we have an exponent 1/2 here. So this is now our given. We have to get dy over du in this case. So by power rule, we have 1/2 times u raised to 1/2 minus 1, that is u raised to negative 1. Then we bring down this term u for us to have a positive exponent, that is 1 over 2 u raised to 1/2. But u technically is equal to ln of x. So again, from exponential, I put it again into radical form. So this is our u ln of x, and that is square root of ln of x. And again, for our dy or du over dx, okay, this is our u ln of x. So du over dx is simply 1 over x. So using the chain rule, again, formula, we multiply dy over du multiplied by du over dx. So we got this answer. And I hope you are still catching up with our lesson. Okay? So for number 7, problem, y is equal to x ln of x. So as you can see, this can be rewritten as x, okay, ln of x. That is a multiplication. We use product rule here. Again, first, we copy the u. Our u is x. We differentiate ln of x, u dv plus v du. So we have 1 over x plus, okay, copy the v, that is ln of x, and then differentiate the x, that is 1. So x would cancel here. So what will happen? We have a 1 plus ln of x. So this is our answer for this problem. Okay? So how about for number 8? We have number 8 is x squared. Okay, y is equals to x squared logarithm of 3 minus 2x of base 2. Okay, so again, we have a product rule here. So we're going to get first or copy first x squared and then differentiate this second term. Okay, so how do we differentiate this? Our a in this case is 2. Okay, if we recall our formula, if we get this, that is 1 over our whole x is this 3 minus 2x. Okay, ln of a, which is 2. Okay, but since again we have an inside function of 3 minus 2x and not only x, we need to get the derivative of the inside function 3 minus 2x with respect to x. So that would be what? 3 minus 2x, the derivative of this, that is multiplied to this, derivative of this is negative 2. Okay? Plus, okay, that is u dv plus v du. Our v is logarithm of 3 minus 2x, okay, with base 2 multiplied by the derivative of x squared, that is 2x. So what will happen? Let me just go here. So what will happen here? X squared times negative 2, that is negative 2x squared over, okay, 3 minus 2x ln of 2 plus 2x over, not over, 2x log of 2x log of 3 minus 2x with base 2. So this should be our final answer. Again, so what happened here is again the chain rule. Okay, so we use the chain rule here. So in order for us to fully understand, again, let me go back to our example. An easy example, we have logarithmic of 2, logarithm of 3 minus 2x with base 2. So how did we come up with this derivative? 1 over 3 minus 2x ln 2 multiplied by negative 2. So we use the formula again. Okay, to get the dy over dx here, I can let you as what? 3 minus 2x, I let you. So in order to get dy over dx, again, we have to use the chain rule. We have, what is our formula a while ago? That is dy over du times du over dx. So our dy with respect to u is simply, we can get dy over du, this is our y. So that is by formula, we have 1 over, okay, we have u ln of a, which is the 2. So 1 over u ln of 2, that is 1 over, our u is simply, u is equals to 3 minus 2x. So 3 minus 2x multiplied by the ln of 2. Okay? And again, our u, we will get du over dx of that. That is negative 2. So if we plug in to this formula of chain rule, dy over dx, we have dy over dx 1 over 3 minus 2x times ln of 2 multiplied by, that is multiplied by d over dx, negative 2. So we have the answer as negative 2 over 3 minus 2x ln of 2. So it happens that we have an x squared here because this is a product rule. So, but in this example, the answer would be negative 2 over, okay, 3 minus 2x times ln of 2. So this should be our answer for this problem. Okay, that's how we got the negative 2 over 3 minus 2x ln of 2 in our previous problem. Okay, and I hope you can follow it, okay, by chain rule. Alright, let's go to another problem. So we have Number, I think, what number are we? Number 10. Problem number 10. We have y is equals to x squared over 1 plus log of x. Okay? So our logarithm here is log of x. Simply, we have a base 10 here. Even though it's not 310. It's understood that this is base 10. So this is a quotient rule wherein we are going to get perform quotient rule here. So we copy the denominator. We multiply it by the derivative of the numerator. We have 2x minus, again, okay, copy the numerator and multiply it by the derivative of the denominator. In this case, we have log of x or 1 plus log of x. So derivative of 1 is 0 plus the derivative of log of x, that is 1 over, okay, x ln of 10. Okay, x ln of 10. This is our x. Our a here in this case is 10 over 1 plus log of x squared. We squared the denominator. So that's the formula for quotient rule. So we have 1 plus log of x. I ought not to distribute 2x. Okay. So we have x squared multiplied by 1 over x ln 10. So obviously, this would cancel. So we have here for our second term here as answer as x over ln of 10 over, okay, 1 plus logarithmic of x squared. So that is our answer for this problem. Okay. So for number 11, we shall try y is equals to ln of the ln of x. Ln, natural logarithm of the natural logarithm of x. So first, chain rule, we have to let u the ln of x. So we have to let u, so u is equals to ln of x. Going to use chain rule, du over dx, that is 1 over x. Okay? That is our y. Okay? And what will happen here, again, in order for us to get dy over dx, we have to use the formula dy over du multiplied by du over dx. So we have the du over dx, which is 1 over x. We're going to get dy over du. dy over du is simply the derivative of y with respect to is 1 over u. But u is equal to ln of x. So we have 1 over ln of x. So we multiply the two. We have dy over du is 1 over ln of x. Okay. And we multiply it by du over dx, which is 1 over x. So our answer would be 1 over x ln of x. So pretty much easier, right? So some of the students are really confused with this ln of m, ln of the ln of x. How do you find the derivative of that? You must use a chain rule in evaluating such problems. Okay, so for another problem, we have number 12. I think that is y is equals to ln of the tangent of x. Okay, so again, we let u is equals to tangent of x. We have du over dx. Derivative of tangent is secant squared x. Okay, then our given now is ln of u. So if we get the dy derivative of y with respect to u, so that is simply 1 over u. But our u is simply equal to tangent of x. So in order for us to get dy over dx, or the derivative of y with respect to x, we have the chain rule again, dy over du multiplied by du over dx. So dy over du is 1 over tangent of x multiplied by du over dx. Okay, that is secant squared x, or secant squared x. So we have secant squared x over tangent of x. We can further simplify this. So 1 over, we know that 1 over cosine x is equal to secant x. But this is squared, so we have 1 over cosine squared x over tangent of x is equal to sine of x over cosine of x. So you have sine of x over cosine of x. So this would be cancelled, the cosine. So we have now 1 over cosine of x over simply just sine of x. By simplification, this is a division. We get the reciprocal and we multiply it by 1 over cosine. So what will happen? That would be 1 over sine of x. And our answer would be 1 over sine x cosine of x. Okay, again, our answer is 1 over sine of x cosine of x. Okay, or you can have this as your final answer. Okay, if you want it to be more simplified, this is our answer. Okay. Okay, next problem, we have number 13. We have a y is equals to cosine of ln of x. Now, we have to let u as equal to ln of x. So, our given would now be cosine of u. So, we have to get the du over dx, that is simply 1 over x. Of course, we have to get dy, derivative of y with respect to u. Okay, derivative of y with respect to u, cosine of u is simply negative sine of u, but u is equals to ln of x, negative sine ln of x. Now, by chain rule, our dy over dx is equal now to dy over du multiplied by du over dx. So, our dy over du would be negative sine of the ln of x multiplied by du over dx, that is 1 over x. So our answer for this problem should be negative sine of the ln of x over x. Okay, so this is our answer for this problem. And last, for our problem number 14, we have y is equals to the logarithm of sine squared x. So how do we differentiate this? Again, we have to let u is equal to sine squared x. Okay, so sine squared x. And this is also equal to sine of x squared. So if we get the derivative of u with respect to x of this, we have 2 sine of x. Okay, 2 sine of x. So power rule, chain rule, I mean, 2 sine of x, 2 raised to 2 minus 1, that is sine of x, multiplied by the derivative of sine x, that is cosine of x. So we have du over dx as 2 sine of x cosine of the x. Okay, so what will happen? We have to get dy over du. So our given is now replaced by log of u. Okay, if we get the dy over du of this would be 1 over u ln of 10. By the formula, our a here is 10, even though it's not written. Okay, 1 over u ln of 10. But our u is equal to what? Our u is equal to sine squared x ln of 10. So in order for us, again, let me just rewrite here. Again, to get the dy over dx, that is dy over du multiplied by du over dx. And our dy over du is 1 over sine squared x ln of 10 multiplied by the du over dx, which is 2 sine of x cosine of x. As you can see, this sine x would be cancelled by 1 term of sine x here. Okay, so what will happen is that We have a numerator times numerator. That would be 2 cosine of x over sine of x ln of 10. But if you would notice, this cosine over sine as a trigonometric identity, cosine over sine of x is equal to cotangent of x. So we'll have 2 cotangent of x over ln of 10. So this is our final answer. And that's it, guys, and I hope you learned something for today's video all about the derivatives of logarithmic function. If you find this video helpful, please don't forget to click subscribe and like, and please comment down below your thoughts. Thank you so much. Again, this is Engineer Abat. Have a great day and God bless us all.